Welcome to reneenergy.com, your renewable energy and sustainability platform. At reneenergy.com, we believe in the power of clean, sustainable energy to transform the way we live and work. That's why we offer a range of solutions for businesses and homeowners looking to switch to renewable energy sources such as solar, wind, and water. Welcome to the reneenergy.com YouTube channel, your go-to source for all things green and sustainable in the energy sector. Today's world is at a pivotal crossroads in energy consumption and production. As we face the challenges of climate change, the shift towards sustainable energy sources has become more crucial than ever. One of the most promising and innovative solutions in this journey is green hydrogen. Heralded as the fuel of the future, green hydrogen is not just a clean energy source, it's a beacon of hope for a carbon-neutral future. In today's episode, we delve deep into the world of green hydrogen, specifically focusing on its feasibility across various critical industries. We'll explore how industries like cement, chemical, steel, and power can transition to green hydrogen, the challenges they face, and the potential impact of this shift. Join us as we unravel the complexities and uncover the possibilities of green hydrogen, paving the way for a sustainable and greener tomorrow. Section 1. Green hydrogen in the cement industry. Overview of the cement industry's environmental impact and the potential role of green hydrogen. The cement industry, essential for infrastructure development, is a major contributor to global carbon emissions. This industry is responsible for over 4 billion tons of CO2 annually, making up 8% of global emissions. The process of producing cement, primarily through the firing of limestone and clay, is energy intensive and releases significant amounts of CO2. In this context, green hydrogen emerges as a potential transformative solution. Technological advancements and green hydrogen integration. The integration of green hydrogen in cement production is a part of the broader energy transition in the sector. Technological advancements complement the role of green hydrogen. This integration is particularly promising as green hydrogen, being a sustainable way to store and move energy, aligns with the industry's push towards decarbonization. Firing cement kilns with green hydrogen. The adoption of green hydrogen in cement kilns is advancing, with trials in Europe aiming for 100% fossil fuel substitution. Combining green hydrogen with natural gas is seen as an effective method to decarbonize electricity and heat production in the cement industry. Managing hydrogen in cement plants. Handling hydrogen in cement plants requires precautions due to its flammability and buoyancy. The integration of hydrogen in cement kilns can impact the refractory materials and potentially increase NOx levels, necessitating careful management of hydrogen injection and oxygen concentration. Co-locating electrolyzers and utilizing byproduct oxygen. An additional benefit of integrating electrolyzers in cement plants is the availability of byproduct oxygen. This oxygen can enhance the cement production process by providing a shorter and more stable flame, enabling higher quality clinker production. The path to decarbonization. While the cement industry has made progress in reducing its environmental impact, the path to full decarbonization remains challenging. However, the use of mature technologies and green hydrogen generated from renewable sources offers a promising way forward. In summary, the adoption of green hydrogen in the cement industry presents a crucial opportunity to reduce its substantial carbon footprint. Despite the challenges of high costs and the need for new infrastructure and technologies, the potential benefits of reduced CO2 emissions, enhanced energy efficiency, and sustainable production processes make it a compelling path for the industry's future. Section 2. Green hydrogen in the chemical industry. Role of green hydrogen in the chemical industry's shift to sustainability. The chemical industry plays a crucial role in the global economy and is pivotal in the transition to a sustainable and circular economy. However, this sector faces significant challenges in achieving net zero emissions. Green hydrogen emerges as a critical enabler and an opportunity for the industry, not only aiding in achieving net zero but also opening up new sustainable revenue streams. To fully realize the potential of green hydrogen, the chemical industry needs to go beyond energy efficiency and bio-based feedstock, exploring innovative solutions like green hydrogen, carbon capture, and electrification. Current use and future potential of green hydrogen in the chemical industry. Currently, the EU industry uses about 10 million tons of hydrogen, mainly for producing ammonia and in refining. Most of this hydrogen is gray, produced in a carbon-intensive manner. The shift towards low CO2 hydrogen, specifically blue and green varieties, is crucial for decarbonization. The hydrogen market is expected to grow significantly, with projections of over 100 million tons by 2050. This growth underscores hydrogen's emerging role as a main energy carrier in the future EU energy system, with applications in industry, sustainable fuels for transport, and as a sustainable chemical feedstock. Investment and global initiatives in hydrogen development. The emerging hydrogen economy is garnering support from policymakers at both European and international levels. An estimated investment of €430 billion is required by 2030, highlighting the industry's commitment to and interest in hydrogen. This investment is crucial for developing hydrogen projects and addressing the urgency to act now. Countries outside Europe, like China, are also formulating hydrogen strategies, with the demand for hydrogen in China expected to reach 60 million tons annually by 2050. Challenges in scaling up green hydrogen. The scaling up of green hydrogen faces several significant challenges. 1. Technology readiness and cost. Improvements in electrolysis and fuel cell efficiencies are necessary for cost-effective hydrogen production. The cost of green hydrogen production needs to be competitive with conventional fuels. 2. Infrastructure development. Large-scale hydrogen production facilities and robust distribution networks are essential. Investments in production capacity and storage solutions are critical. 3. Market off-takers and customer acceptance. Creating demand and convincing market off-takers of hydrogen's benefits is vital for market development. 4. Financing and investment. Overcoming the capital-intensive nature of hydrogen scaling requires attracting investments and developing innovative financing models. 5. Supply chain bottlenecks. Addressing the availability and sourcing of raw materials and ensuring an adequate supply of critical equipment is necessary. 6. Policy frameworks. Supportive policies and regulations, financial incentives, and international collaboration are key to fostering green hydrogen adoption. The chemical industry's transition to a more sustainable portfolio through green hydrogen is a complex but feasible endeavor. It requires strategic choices, technological advancements, substantial investments, and supportive policies. Addressing these challenges collaboratively can help the chemical industry make a profitable and sustainable shift to green hydrogen, ultimately contributing to global decarbonization efforts. Section 3: Green hydrogen in the steel industry. The steel industry's carbon footprint and the role of green hydrogen. Steel, a cornerstone of modern construction and engineering, faces immense pressure to reduce its carbon footprint. As one of the largest CO2 emitters globally, the steel industry's transition to lower emissions is both an environmental necessity and an economic imperative. Every ton of steel produced results in approximately 1.85 tons of carbon dioxide, contributing to about 8% of global CO2 emissions. In this context, hydrogen-based steel production, particularly using green hydrogen, emerges as a critical strategy for decarbonization. Implementing hydrogen-based steel production. Transitioning to hydrogen-based steel production can be approached in both new, greenfield, and existing, brownfield, facilities. This involves retrofitting existing electric arc furnace, EAF, plants or rebuilding facilities to incorporate green hydrogen in the production process. Decarbonization strategies will vary depending on location, technical feasibility, infrastructure, market demands, and the regulatory environment. Direct reduced iron, DRI, and electric arc furnace, EAF, using hydrogen. A key method in this transition is using green hydrogen-based direct reduced iron, DRI, combined with EAFs. This process replaces fossil fuels with hydrogen produced from renewable energy, leading to nearly emission-free steel production. The hydrogen can be used as an alternative reductant to produce DRI, which is then processed into steel using an EAF. This DRI/EAF route, currently employed using natural gas, can be adapted to use green hydrogen, significantly reducing carbon emissions. Challenges and cost dynamics. The transition to green hydrogen-based steel production involves several challenges. 1. Green hydrogen production. Producing green hydrogen requires significant electricity from renewable sources, posing a challenge in ensuring sufficient and steady supply. 2. Cost of green hydrogen. While currently higher than gray hydrogen, the cost of green hydrogen is expected to decrease, driven by falling costs of renewable electricity and electrolyzers. 3. EU Emissions Trading System, EU ETS. The EU's cap and trade strategy for CO2 emissions is influencing the economic dynamics, making green hydrogen-based steel production more viable as carbon dioxide prices increase. By 2030, the cost dynamics are expected to shift, making green hydrogen-based steel production more economically competitive. This shift will be crucial for the industry, especially in Europe, where stringent emission regulations are in place. Decarbonization tipping points. The timeline for the industry's transformation to green hydrogen-based steel production is influenced by various factors. 1. Power supply. The need for increased capacity and electricity derived from renewables is crucial for this technological shift. 2. Hydrogen supply security. Ensuring the availability of green hydrogen on an industrial scale is fundamental to the production of hydrogen-based steel. The steel industry's journey towards green hydrogen-based production is not just a response to environmental challenges but also an opportunity to reshape its future. While the path involves overcoming significant technical, economic, and regulatory challenges, it holds the promise of transforming one of the world's most carbon-intensive industries into a more sustainable and environmentally responsible sector. Section 4: Green hydrogen in the power industry. Transformative potential of green hydrogen in power generation. Green hydrogen is increasingly recognized as a game changer in the power industry. It offers a cleaner burning alternative to conventional fuels and is pivotal in the transition to clean energy. The power industry can significantly benefit from the versatility of hydrogen, especially in terms of reducing carbon emissions and advancing towards a sustainable energy future. Advancements and feasibility studies in green hydrogen production. Although the current cost of producing green hydrogen from renewable sources is high, the momentum along the value chain is driving cost reductions in its production, transmission, distribution, and end applications. Sectors like oil refining, ammonia, methanol, and steel production are already extensively using hydrogen. In power generation, hydrogen has the potential to play a critical role, particularly in sectors such as transportation, buildings, and power generation itself. Current role and future integration of hydrogen in power generation. Currently, hydrogen accounts for less than 0.2% of electricity generation. However, the integration of hydrogen, particularly in the form of ammonia, can significantly decrease the carbon impact of conventional coal-fired power plants, hydrogen gas turbines, and combined cycle gas turbines, CCGT. Hydrogen is also crucial for long-term and large-scale energy storage, balancing seasonal variations in electricity supply and demand from renewable sources. Global initiatives and market growth for green hydrogen. Several countries are considering a hydrogen-based economy to address carbon emissions, energy stability, and climate change. For instance, the EU's hydrogen strategy targets a renewable hydrogen electrolyzer capacity of 6 gigawatts by 2024 and 40 gigawatts by 2030. Similarly, India's National Hydrogen Mission aims for significant green hydrogen production by 2030, and Australia plans to establish hydrogen hubs to leverage existing or potential hydrogen markets. These initiatives underscore the growing market and the strategic importance of green hydrogen in the global energy transition. Challenges in transitioning to hydrogen power plants. Transitioning to hydrogen power plants entails various technical and infrastructural challenges. These include developing combustion system technology capable of operating on mixtures of natural gas and hydrogen, addressing the impact on exhaust gas characteristics, and ensuring compliance with NOx emission regulations. Furthermore, the transition requires significant infrastructure investment, particularly for electricity, port, and water services. Customizing the distribution of hydrogen to suit customer requirements is another critical aspect, whether in gaseous or liquid form. The incorporation of green hydrogen in the power industry represents a significant step towards decarbonization and a sustainable energy future. While the challenges are notable, the ongoing technological advancements, feasibility studies, and global initiatives are paving the way for more extensive integration of hydrogen in power generation. This transition not only supports environmental goals but also positions hydrogen as a key component in the future energy landscape. Key takeaways. 1. Cement industry. Green hydrogen can significantly reduce CO2 emissions. Challenges include high production costs and infrastructure needs. 2. Chemical industry. Green hydrogen offers new sustainable revenue streams. 2. Key obstacles include technology readiness and market development. 3. Steel industry. Transitioning to green hydrogen-based production is crucial for reducing carbon emissions, with challenges in cost and technological adaptation. 4. Power industry. Green hydrogen has transformative potential for clean energy transitions, facing challenges in integration and infrastructure development. Importance of green hydrogen. Green hydrogen stands as a pivotal sustainable energy source, crucial for decarbonizing various sectors and paving the way towards a greener future. Embark on a journey of discovery and innovation with our specialized feasibility study templates for green hydrogen applications in the cement, chemical, steel, and power industries. These in-depth resources are available for you at reneenergy.com. Access these templates to gain essential insights into the sustainable implementation of green hydrogen, enhancing your understanding and involvement in this transformative energy sector. Visit reneenergy.com now to explore these valuable materials and take a significant step towards a sustainable future with green hydrogen. Thank you for choosing Reneenergy.